This is the answer key. Jump ahead if you want to listen to the review video, and also some of these problems are out of order or not included in your review. All right, number one says to use the given graph to find the Riemann sum with 6 subintervals. So 6. Take a sample point to be the left endpoint. Okay, those are two important pieces of information we need. And so we're going to use the left endpoint and divide it into 6. So it goes from 0 to 6. So 6 minus 0 divided by 6. It's 1 unit for each subinterval. And going from the left, we want to find the area of each of these boxes. All right, so area here, in the first one, the height is 2, and delta x would be 1, so 2 times 1. Plus, the next one, the height is about 3.5 times 1. And the next one, 4 times 1. And then we'll go to the next. 2 times 1. The next one, that's a negative, so a negative 1 minus 1 times 1. And then this one's negative as well. Remember, if it goes down under the x-axis, it's negative. So minus 2.5 times 1. Add all that up, and you get an 8. That's what you have to do there. Number 2, the speed of a runner increases steadily during the first 3 seconds of a race. Her speed at half-second intervals is given in the table. Find the lower estimate for the distance that she traveled during those 3 seconds. Let's look back up here at number 1 for a second. For this one, it looks like this is an underestimate. Okay, just because of it. It may not be. It's really hard to tell because of where it increased and then decreased again. It's harder to tell. But here, where it is increasing, steadily increasing, we want the lower estimate. So the lower estimate is going to be the left hand. So it doesn't tell us, but I'm going to break it into these. Okay. They're half-second intervals, so I'm going to do 0.5 times, and I want the left-handed side. So a 0 plus 3.7 plus an 8.3, because these are all the left-hand sides, plus a 13.2 plus a 15.1 plus 15.7, and then forget your delta x, okay? And that comes out to be a 28. So you had one where it was graphed, one with a table, and now one with an equation. So this one says to evaluate the Riemann sum for f of x equals 9 minus x squared. And between 0 and 2 with 4 subintervals, and we're going to use the right endpoint. So here we go. Using the right side, that means that we don't want the 0. We want to start with a 2. And we're going to break it into 4 subintervals. So 2 minus 0 divided by 4 is 0.5. So you're going to need to use, move it to the side here. You're going to need a 2. So f of 2. Plug 2 into the equation, and you get a 5. F of 1.5. And notice I'm starting from the right side, like we saw in class, because it's the right endpoint. It's easier to start at the right side and work our way backwards. And so 6.75, plug that in. F of 1, 8, and f of 0.5 is 8.75. And then we don't want to use the 0 because we don't use that side. And these are all half, so add those up, it's 28.5. And it's delta x is 0.5, so multiply by 0.5, and we get 14.25. Number 4, same thing here. In this 5, 3 decimal places, and this one's a midpoint. So we did a table, a chart, a graph, left endpoint, right endpoint, talking about if it's a lower estimate or an upper estimate, and then now midpoint. So 6 minus 1 is equal to 5, and 5 divided by 5 is 1. But we want to take the midpoint. So the midpoint between 1 and 2 is 1.5. So f of 1.5. And the reason 1 to 2 is because we start with 1. The next one interval is 2. And I get a negative 0.77526, 2.5, negative 0.41886, f of 3.5 is negative 0.12917, f of 4.5, 0.12132, and f of 5.5, 0.34521. Add all of those up, and I get negative 0.857. Multiply it by my delta x, which is 1, and I get negative 0.857. All right, this might be one of the easiest questions on the test. This next one, don't need a whole lot of room for it. It says evaluate this definite interval. Now, you have it on your paper, but zooming in, I know it's not real clear when I get closer. But this is pi over 8. And this down here is negative pi over 8. Now, to me, I'm seeing that, I'm thinking, I wonder if this function, if I graphed it, would be symmetrical above and below the x-axis, meaning the same area above and the same area below. I graph it and I notice it does. So the area, or the integral, is equal to 0. So look for those things. If it's the same, graph it and see if it looks like it would be the same above and below, which that's what it's talking about, that one is. Number 6, it says the velocity function in meters per second is given for the particle moving along a line, find the distance traveled. So if the velocity, the position function is the interval. So the interval of 4t minus 3 from 0 to 6. I know this is linear, so I don't need to worry about that. And I need to figure out the distance traveled. So the integrals increase, derivatives decrease. So we're going to increase the power. So 4 over 2 minus 3t. And this is a definite integral. So from 0 to 6, I don't need the c. Plug it in. Just being sure that this doesn't go below the x-axis before it hits 6. And it doesn't, but you may want to check it out yourself. And so this is going to be a 2 times 6 squared minus 3 times 6. If I plug in a 0, it's just going to be 0, so minus 0. And this becomes 54. So 54 meters. All right. Next one. This one's fun. This is another easy one. This is 0 to 6 is 10. 0 to 4 is 7. So what would 4 to 6 be? So we're just going to go and take integral from 0 to 6. I'm not going to write the other stuff behind it. you probably should. Don't do what I'm doing. And subtract them, because that will give us a 4 to 6. So that's 10 minus 7 is 3. Sorry, I just didn't do it because I was running out of space. Don't give me that excuse on your test. I didn't do it because I was running out of space. You guys grab another sheet of paper. All right, so number 9, find the area of the region that lies under the given curve. And it's from the interval from 0 to 1. And round it to the nearest hundredth. So I want to take the integral from 0 to 1 of 5x plus 2 dx. Now this has an inner function. Hint there, when you see the inner function, that means you need the u stuff. So u is equal to 5x plus 2. du is equal to 5 dx. Okay, so I need to do some substituting in. I'm going to take off the 0 to 1 for now because I'm going to change the variables, and so that wouldn't be the same. So this is going to be the square root of u, and I need a 5. There's nothing I can use, so I'm going to put a 5 dx there. And if I put it inside here, I can't just add this 5. I need a 1/5 out front. So this is going to be the integral of 1 over 5 in the front, square root of u, I'm going to write that as u to the 1/2, and then du. This is 1/5 times, I'm going to increase it, so that's going to be 3/2, multiply by the reciprocal out front. Now that I have that, I can substitute back in. So this is going to be 2 over 15, and then a 5x plus 2 to the 3/2, and it is over the interval 0 to 1. So I'm going to plug in the 1. And subtract off when I plug in the 0. Oops. That needs to be 0. And that gives me a 2.092. Number 9, we're going to evaluate this indefinite integral, so it's not over a specific range. So I need to figure out what u is, and always look at the inner function. So u is equal to 6 plus 4x plus 3x squared, and du is equal to, it's going to be a 4 plus 6x, and check it out, it matched. Yay! So I have the integral of 1 over the square root of u du. So this goes together to make the du. So the integral of u to the negative 1/2 du, moving over, whoop. Okay, that's better. Integrals increase, so I want to increase it by 1, so that's going to be u to the 1/2, multiply by the reciprocal, so that's going to be a 2, and then plus c, because it's indefinite, not a definite, and then plug u back in. u6 plus 4x plus 3x squared to the 1/2 plus c. That's my answer. Number 10, evaluate this by interpreting in terms of area. So this follows the one group work that you did. So what you want to do is graph this so it crosses the x-axis at 1, it's the y-intercept, and then I'm going from 1 to 3, so 1, 3. My slope is 4, so up 4 over 1. Right here. It's going to keep going up. And it would be this area right here that I want because I'm going to 3. So the height on this one is going to be 13. The height here was 5. This is the trapezoid. It's 1/2 B1 plus B2 times the height. The height is going to be this way. So it's 2. H is 2. B1 is 5 and B2 was 13. So it gives me a total of 18. This one's not too bad. It says to evaluate the sum as a single integral in the form like this. So just asking you to combine. So right here, both of them are 8s and it has the same function. So this is equal to the integral from 2 to 11 of f of z dz. And that's it. That's all we want to do there. Just put it together. Find the derivative of this function. So it's a number going to x. So f prime of x is equal to, I just need to replace it with x's. I'm done. Now remember, it's different if this is an expression. You have to do a little more work. All right, 13. Evaluate this integral. It's a definite integral. And the integral of sine is negative cosine. And it's a definite one, so we don't need the c, but it goes from pi over 6 to pi over 4. And then writing it out, this is going to be negative cosine of pi over 4 minus a negative cosine of pi over 6, which is interesting here. Notice that this becomes a plus, and so that would be cosine of pi over 6 minus cosine of pi over 4. And really what happened was, if these two flip, you don't have to do this right now, it just changes sign, so I could flip it, and that would work. So the cosine of pi over 6 is the square root of 3 over 2, and the cosine of pi over 4 is square root of 2 over 2. So this is the square root of 3 minus the square root of 2 all over 2. That's 13. 14. Evaluating this integral, it has an inner function, so we need a u. So this is u equals x cubed. Du equals 3x squared. I'll check it out, it matches. So this is the integral of cosine of u du. And so that's going to become sine of u, and that would be sine of u with x cubed from 0 to 1. So this is going to be sine of 1 cubed minus sine of 0 cubed. Sine of 0 is 0. Don't know what the sine of 1 is, unless I put it in my calculator. Make sure you put it in radians. This is 0.8415. 15. Evaluate this integral. It has an inner function. The inner function is cosine, so u is equal to cosine of x. So du is equal to negative sine x dx. You know what? Up here, I forgot. There's a dx right here. My apologies. So plugging in, this is going to be the integral of 2 sine x cosine u dx. Then I have this and this, but I'm missing a negative. So if I want to add a negative there, I've got to add a negative out front. I'm going to go ahead and pull this 2 out front too, because I don't need it. and it's a coefficient, so we're good. And then this is the cosine of u, and then I'm going to group negative, because remember that negative and negative is a positive, and I need this negative. Sine of x dx, now that's du, so -2 integral of cosine of u du. The integral of cosine is sine, so sine of u, plug back in the cosine. And let's see, was this indefinite or nope? So we need the plus c. And that is my answer. All right, the last two problems. When I first did 16, I'll tell you what I did. I didn't read closely. And so I need to be careful about what I'm reading. It says Alabama Instrument Company has set up a production line to manufacture new calculators. The rate of production of these calculators after 2 weeks is this function, calculators per week. Production approaches 4,500 per week as time goes on, but the initial production is lower because the workers' unfamiliarity with the new techniques. Find the number of calculators produced from the beginning of the 3rd week, which is also the end of the 2nd week, because it's after, to the end of the 4th week. Be careful. Not saying whether your test has one that is confusing or not, but pay attention to the wording, okay? Because I did not when I first did this problem. So I need to find the integral from end of the 2nd week, so 2 to the end of the 4th week of that function. So 4,500, 1 minus 130 over t plus 9 squared dt. All right, so I'm going to go ahead and distribute this in. Maybe I should just move it over. Yeah, that'll be better. 4,500 minus 585,000 over t plus 9 squared dt. Now this one I can split. So this 4,500, when I take the integral of it, it's 4,500 t minus, now I have to take care of this other part. So I have an inner function. So u is equal to t plus 9. du is equal to 1. So I'm just going to carry this down. And don't forget your minus sign. But this is what becomes here. So this is the integral of 585 over u squared. This will be a du because it's a 1, so we don't have to take care of any of that. So rewriting it with a negative exponent. And keep moving down. Oh, don't need that this time. Because now I can increase, so 585,000, u to the negative 1, and then 1 over negative 1, so that's a negative 1 out front. And now let's bring all that stuff down from up here. Maybe. Oh, I didn't do what I wanted it to do. All right, now it'll do it. So bringing it all down, it's 4,500t minus a negative 585,000 over u, and u I know is t plus 9. So I'm going to go ahead and erase that and plug in a t plus 9. All right. A negative and a negative, that makes a positive. So this is a plus. And I need to find it from 2 to 4. I plug in the 4, gives me 63,000. I plug in the 2, gives me 62,181.81. So this is 818. So those 2 weeks, they made 818 calculators. Last one, 17. The marginal cost of manufacturing X yards of a certain fabric is this function. Find the increase in cost if the production level raised from 500 to 3,000. So I'm going to go the integral from 500 to 3,000 of 3 minus 0.01x plus 0.123, 5 zeros, 6x to the second. So integrals increase. So this is 3x minus, and it's going to be 0.01x to the second divided by 2 plus 0.12345. This is going to be over 3. And then from 500 to 3,000. Don't need the C on this one because it just subtracts back off. So plugging in, well, let me go ahead and simplify this. Plugging in 3,000, I get 18,000, and the 500, I actually just get 500 back out, and that gives me $17,500. That's it, guys. Hope that helps.